Hey guys, it's me, Matt,
And I'm Josh.
and this is Singing for Science. Over this next week, while we're on choir tour, we're going to talk to you about energy, or should I say sing to you about energy. Get it? Because
We're on choir tour?
we're not going to sing to you. It's too hard. We're not going to.
Don't worry.
So, what is energy? And what types of energy are there?
How can energy change?
These are just a few of the questions that we're going to answer over this next week. So, tune in next time.
Alright, so we're here on the bus late at night. It's really, really late, like midnight. And looking around, there's not a lot of potential energy here. Everyone's pretty wiped out. There's no kinetic energy either.
Josh, just no, stop. It's not what those are. You're gonna confuse them, okay? You need to tell them what the right answers are. Alright. Really, there's actually a ton of kinetic energy right now because we're on a moving bus for the next 20 hours straight. It's gonna be fun. But anyways, potential energy and kinetic energy are so much more than just somebody moving or having actual energy to do something. But, that's a pretty long conversation. It's getting kind of late, so we're going to tell you all about that tomorrow in our next episode. Yeah. So we're going to go to bed. Catch you later.
Night.
So to explain potential and kinetic energy just a little bit more, we have these two items and a few examples. So for kinetic energy, we have this football. Now, when I throw this football, it has kinetic energy because it's moving. The work that my arm puts on the football causes it to have kinetic energy. Now, the faster I throw this football, the more kinetic energy it has. We know this because kinetic energy equals 1/2 times mass times velocity squared. So the faster that it's going, the more kinetic energy it has. So for potential energy, we have this airplane here. Potential energy is determined by mass, height, and gravitational pull. So the higher up an object is, the more potential energy it will have. And the heavier the object is, the greater potential energy it has. So now it's time to put the two of them together. As Josh goes down the slide, he is losing potential energy and gaining kinetic energy. Woo! But remember, energy isn't just lost. Energy is actually changing from potential energy when he's on the top of the slide to kinetic energy right before he hits the bottom. Woo! He is also losing a little bit of energy to friction through heat, through the slide. Woo! Another type of energy is spring potential energy, and this seesaw demonstrates it perfectly. Now, spring potential energy depends on a couple of things. First, it depends on the K value of the spring, and then it also depends on the X value, the distance that you stretch the spring. Like I said, this demonstrates it perfectly. As you can see, the springs are compressing and expanding with the force put on them. Plus, who doesn't love a seesaw of science? Well, that's all for now. See you next time.
We're home. But even though the singing is done, the science hasn't stopped. Now that Matt's explained everything, let's walk through the different forms of energy one more time. Kinetic energy is the energy of motion. If an object is moving, it has kinetic energy. Looking at the formula for kinetic energy, we know that the greater the mass or velocity of an object, the more kinetic energy it will have. An object's potential energy depends on its surroundings and conditions. Here's the simplest example of potential energy. If an object is above the ground, like I am in the picture, then it has potential energy. Again, looking at the equation for potential energy, we know that energy increases with mass and height, and gravitational pull if you happen to be somewhere other than Earth. Spring potential energy as you can probably guess, is another type of potential energy. When a spring is compressed, releasing the spring and any object attached will cause that object to move and have kinetic energy. Therefore, when a spring is compressed by work, there is potential energy added to the object. Finally, remember that energy is never created or used up, it just changes form. For instance, doing work to climb the slide increases my potential energy. As I allow myself to slide down, this potential energy is transferred to kinetic energy. I slow down at the end because I lose energy through heat by friction to the slide, not because the energy is disappearing or being destroyed.